everyone. Welcome to this session. My name is Ron Bernstein. I'm one of the co-hosts here this afternoon. This session is being sponsored by an organization called the Gridwise Architecture Council. Anybody ever hear of the Gridwise Architecture Council? Probably not. GWAC, Gridwise Architecture Council, or GWAC, is a U.S. Department of Energy funded think tank that works on the North American power grid future state and how the North American power grid needs to interact and adapt and change over the next 25 to 50 years to meet the energy demands of the future, to meet the resiliency, to manage how distributed energy resources and the interconnection with buildings and transportation. So I'm the chair of the council. We're an elected council of think tank members from across the industry. We partnered here with the HR Expo for many years. We're doing another session right after this in S226 on exactly that, the grid future state and how buildings and smart interactive buildings will guide the future. But because of what our relationship is between HR Expo and ASHRAE, we have our ASHRAE members here, myself and my two partners here, that have kind of converged in a three-way presentation where we took an ASHRAE, what we normally do is an ASHRAE seminar, and we're bringing it here to the HR Expo to talk about workforce development and the lack of a pipeline for workforce coming into our industry, and what we're seeing, what are the trends, and what are some of the programs and things that we're working on. So that's what today's session is about. One of the first questions people ask me is, what does IYKY stand for? Does anybody not know what IYKY? I do know what it means. I can't pronounce it. If you know, you know. So how many gray-haired people in the room here? All right, we're if you know, you know. If you don't know, don't bother. I'm not going to teach you how to do that. We're moving beyond that. So that's what this session is about today, moving beyond the old way of doing things into a more harmonious way of getting training, getting education, getting the market moving in the right direction. So that's our brief little intro. I'm going to go last. Ariana is going to go first, and then Gregory is going to go second. Come on up, Ariana, and it's all yours. And by the way, we are recording this. These are HR shows. We are recording this. I put it on my website. HR may put it on their website. So feel free to chime in as needed.
This was your slide.
Oh, sorry. I had a slide. That's us.
This is us.
That was us.
Okay. Okay. So I'm here today with Ron and Greg to talk to you about our industry-wide controls training deficit. But before we start, I'd like to introduce our technical committee. So TC 1.4 is a group of volunteers that discuss controls theory and volunteers to create best practices on design and application of HVAC control systems. As a group, we've developed and maintained 6 ASHRAE handbook sections. We conduct research on basic controls issues that we find in the industry, and we develop and sponsor seminars like these at the AHR and ASHRAE winter and summer conferences. So today, as Ron said, we are presenting at the AHR Expo instead of the paid ASHRAE conference because we wanted to bring awareness to this very important topic and reach a broader list of attendees and get some feedback from all of you on how we can work together to solve this really big problem that we have. Our agenda today is 3 sections. I'm going to begin by reviewing the industry-wide training gap and what happens in a project's life cycle when those working on it are not properly trained. Greg will follow, focusing on operating engineers and retro commissioning, and Ron will close us out, focusing on his workforce development project that he's working on. So a little background about myself. I'm currently the Director of Business Development for DAC out of Texas. For the past 8 years, I've been predominantly responsible for pre-construction in Boston, Massachusetts. I focused on sales and business development, but prior to that, I spent 9 years in the field. I began my career in New York City, where I served as an energy auditor, commissioning agent, and then I transferred to a controls contractor where I was a project manager and then ran all of the field technical staff and eventually moved to Boston to start a branch office. So I've seen things from every side of this industry, and the remainder of my presentation is based mostly on my personal experience for the past 17 years in this industry. So personally, like most people in the controls world, I fell into this field. I never received any formal training. I went to school for mechanical engineering, but we only had one class on controls theory with some crazy equations that I will never use again. And the only kind of hands-on experience we had was with PLCs and a green and a red light. DDC wasn't a term I learned until I was in a meeting and my customer asked me if the controls platform that we were proposing was DDC or pneumatic, and I embarrassingly had absolutely no idea what this woman was asking me. So I've come a little bit of a long way. But I mostly learned by trial and error. I've blown up a ton of controllers, burnt out devices, gotten yelled at by GCs for taking too long to fix something. I've underpriced projects that cost me a lot of money. And although learning by making mistakes is a really great method for some, it obviously costs us money. It's super frustrating. It's not efficient. And not everyone will spend their Friday night on site till midnight trying to fix what they broke. So really quick before we get more into it, if you guys can pull out your phones, we want to collect some data from you guys. Hopefully it works. Is it working?
Not for me.
No, perfect. Okay, well, all right. Should we do a little hand raising?
Well, no, go to the next one, because that's actually the poll.
All right, pop up. I got it.
Yeah, get that. Controls, man. All right, what is everyone's job function? Oh no, I ruined it. Okay. A lot of others. I don't know what other consists of. All right, so you got a lot of contractors and a lot of people that do something different. Some consulting engineers. In the essence of time, I'm just going to skip really quick to the next question. What is your building automation system proficiency level? In your own honest opinion, it's anonymous, so. Also, there's a lot of controls contractors here, so you guys are skewing the data. Maybe you guys from tech don't answer. All right, well, we have an entire controls company here, so this kind of doesn't work. But I know a little in what is GWAC. We still have some people that are a little more on the novice side of things. So whether you answered you're an expert or not, control systems as a whole are everywhere. Your toaster, ovens, timer is a very simple open loop control system. And then we get into the more complex control systems of an aircraft or the car we drive every day. So would you trust getting in your car every morning or boarding your plane to Vegas or strapping yourself into this ride if you knew that the control system installed in those in that vehicle was designed and tested by someone that wasn't trained at all? Probably not, right? So if a lack of training is unacceptable for those systems, why is it acceptable that the person responsible for properly pressurizing this clean room isn't trained? Or ensuring there are enough air changes in your kid's classroom during flu season? So our presentation topic is on filling the gap for operators, but there are so many people that touch this control system before it ever reaches the operator's hands. So I've divided the stakeholders in a control system into 6 buckets. We have the consulting engineers, the equipment vendors, contractors, commissioning agents, owners, developers, and tenants. So when a system is designed and installed incorrectly, all the operator training in the world isn't going to help us. So I'm going to touch a little bit upon the trickle-down effect that occurs when the upstream stakeholders are inexperienced. Starting with consulting engineers. They're responsible for developing accurate and consistent design documents that are appropriate for the application. Most of the time, consulting engineers are focused on the mechanical design themselves and leave the controls to the very last minute. They also don't focus enough time on educating themselves on controls. This results in incorrect and inconsistent documents. When the design documents are inconsistent, pricing the job can be confusing even for me. In the world of competitive bidding, some contractors will take that and take liberties and price the cheapest option knowing that they can submit for change orders. And as a general rule, not enough time is spent updating standard specs. So I see the same recycled specification on every project. Examples include requirements for antiquated communication languages, or including products that no longer exist in acceptable contractor list, which opens the door for any contractor to bid. When the standard spec is issued without any edits, this comes with specifying instrumentation that is inappropriate for the application. Things like this industrial grade pressure transmitter, which costs over 1,000 times more than its commercial grade counterpart, which inflates project cost. Or not mandating the correct type of sensors, like an averaging sensor across a large coil cross-section, which creates controllability issues. I often see sequences that don't make sense for the equipment's application, and the engineer must have a working knowledge of controls to provide a comprehensive submittal review. So when these issues are included in documents issued for bid and then purchased, the incorrect design will now flow to the remainder of the stakeholder's scope. So that moves us to the equipment vendor. It is their responsibility to provide adequate controllability of the equipment they are providing. When a unit becomes the packaged controls and the equipment vendor isn't control savvy, it isn't until the equipment is installed and started up that we learn that the sequences just don't align with the application. Or we have missing devices, ones that are incorrect, or ones that are installed in the completely wrong location. I find that the Division 23 specification for the equipment often does not match what's in the controls drawings, and equipment vendors are only reading the Div 23 spec. And then everyone's favorite topic, integration issues. This can range from the controller just not communicating because it doesn't adhere to the BACnet standards, not having the correct controls points exposed to the controls contractor, or not coordinating with the controls contractor, so we install the wrong cable. And just general lack of support. There's often one guy in the entire company that knows anything about the controls, and he lives in Germany or Switzerland, and you have to get on a plane if you really hope to have a conversation with him. Sorry, I'm going to go a little fast because we're a little tight on time. So I've placed contractors into one bucket, but this bucket includes general, mechanical, electricians, and controls, anyone that's involved in installation of the system and responsible for schedule and budget. The prime contractor, whether it's general or mechanical, needs to coordinate the installation. When I was in the field, I'd often have to manage up. I'd take the schedule issued to me that gave me 3 working days to do a complete installation, checkout, and sequence test of a 40,000 CFM custom energy recovery unit and actually add our real schedule. And for those of you that are not familiar, that takes a lot more than 3 days. So we're never given enough time, and this can result in a very stressful situation that costs everyone time and money. The prime contractor also needs to properly level bids from the ATC in order to correctly purchase the job. If they can't level the bid, and this goes hand in hand with having incorrect design documents, they'll often award the cheapest contractor, which isn't always the best contractor. And then when the installing electrician is not up to speed, we have wiring issues. So this is something that I've found on site, probably my favorite, no idea. I've encountered this, that was from the new school, this type of mess when walking retrofit jobs or seeing abysmal panel installations that are just impossible for our techs to troubleshoot. And the actual controls contractor. On the back end, we have the sales engineer. An untrained sales engineer will carry incorrect scope or miss items. An untrained controls engineer will copy and paste from the incorrect design documents instead of catching these issues. This trickles down to the software engineer who will program the incorrect sequence, and they're also responsible for point naming conventions for the operator to effectively operate the building. So if they don't know, they don't know. If you don't know, you know. And then that passes on to the graphics designer to create incorrect flow diagrams. And also super frustrating is not having the correct points assigned to the graphics and changing a set point in a different room. So when this project moves to the field, an untrained project manager can create scheduling delays from improper coordination, pair that with the untrained GC, and you have a pressure cooker, and then our poor technicians. All these upstream issues fall on their head. They're always expected to catch everyone's lack of knowledge at the end of the job when they're doing startup. However, we also have a huge manpower deficit there, and they're often learning on the job, just like I did. This can lead to incomplete system checkout, loop tuning, long commissioning deficiency lists, which lead to excessive meetings and a ton of time trying to clean up the job, needing to do things more than once, and then the operators and service technicians are left with incomplete or inaccurate as-built drawings, and that doesn't allow them to actually clean up the job even after everyone's left. Brings us to the commissioning agent. Faster. More than it.
Okay.
Okay, I'm good. Right, so the commissioning agent is required to third-party verify the system and hold the contractors accountable. I was an untrained commissioning agent. I was learning from the person that I was supposed to be holding accountable. So this allows the contractor to pull the wool over the commissioning agent's eyes, and they can pass their testing even if their system is riddled with issues. And just like the commissioning technician, the commissioning agent will be able to identify issues from the upstream parties. And at the end of the day, the owner is left with a system that just has been verified, but doesn't actually work. And then the owner themselves. It's their responsibility to effectively communicate the needs and expectations of the system, but they often are not familiar with what they're purchasing, and they don't understand how much it costs, which creates budget issues. And they're not bringing their operations staff on during construction. So the operations staff has no input into how the building's going to operate. They don't know where anything is. And they come on board when the contractors are already gone or trying to leave. And then they have 40 hours of training to learn how to operate a 1,000-ton chiller plant and a 70-story building, which just doesn't cut it. And lastly, they also, if they aren't trained, they'll override control points, which defeats the purpose of an automatic control system. This leads to sequencing issues, controllability issues, and wasted energy. And lastly, if the tenant is relying on the base building operator and they're not trained on their portion, the operator will have an excessive amount of calls, which cost the owner time and money. So now that I've vented my 17 years of frustration to everyone, let's talk about why this happens. First of all, there's a complete lack of awareness. Everyone operates in their little bubble of scope, and nobody has a comprehensive understanding of how they impact the big picture. There's also a lack of awareness this trade even exists. I've never met anyone in this industry that wanted to be a controls engineer when they grew up. We all accidentally fell into it. Hand in hand is a lack of adequate training resources and inadequate marketing. I did a quick Google search on building automation degrees, and out of 6 pages, which is about 60 hits, I only found 7 programs. The only bachelor degree comes from Pennsylvania College of Technology. The others are associate's degrees or associate's degrees in something else that allow you to have some sort of focus on controls. In the programs I did find, they had a list of potential jobs and average salaries. To me, this is just not sexy enough to gain any of my attention if I'm a new grad from high school or somebody that's aspiring to be an engineer. It's also vastly inaccurate. So what are we doing to actually attract these young people? The workforce is aging, and since we're not recruiting young people, we're experiencing a greater and greater manpower shortage. With this manpower shortage comes a deficit in time for the people that actually have experience. So instead of training our young people, we're actually doing the work ourselves. And this vicious cycle just continues. And lastly, as an industry, we've just accepted mediocrity. The most common feedback I've received as a professional is that I care too much and that my expectations are too high. I don't know a single other aspect of life where caring too much is seen as a negative feedback. And one of my customers in New York used to say that he liked working with us because we sucked the least. So as an industry, what are we doing? First of all, we're talking about it. So we're here in this free seminar rather than the paid conference to try to raise awareness. And out of the 350 educational courses at this expo, 25% of them have something to do with controls, which is awesome. TC 1.4 committee sessions are very well attended. We have really good discussions. We've developed Guideline 36 to try to help the industry standardize their sequence of operations, but I've never seen this used correctly. The only time I've ever seen it used, the entire document's been pasted into the specification, which makes it useless. For those that don't know, it has every single option, so you need to go through it and actually select which equipment you're working on. So we're not actually using the tools that are available to us. So we're just not doing enough. The building automation industry professionals are making an effort, but there needs to be a heavier focus from all of you. Those that checked off the beginner boxes, spend time educating yourselves. Ask for help. Call me. Those that checked intermediate or ask me anything need to take more time to get involved. Help the educational institutions educate these prospective students on the industry because they also lack people that are able to even teach this topic. I've had so many schools reach out to me asking me for help. And as employers, provide resources to develop your employees, encourage them to educate themselves, use the resources that we do have, and encourage those seeking work to have some sort of entry-level job requirements. And lastly, as industry professionals, we need to hold each other accountable. Call the engineer working on a project that's issued something incorrect and tell them what they did wrong. Do not use it to put an extra dollar in your pocket. When we spend a little extra time mentoring, teaching, using tools that are available to us and helping each other, it does work. I've seen it, and it's a lot more pleasant than what the alternative is. So I'll turn it over to Gregory.
Hey everyone, I'm Greg Tycho. I'm a senior project engineer at TBL Technologies out in New York City. And I will speak on, or my portion of this conversation is focus on operators. I don't know if that was one of the options, but do we have any operators in the room or like maybe at one point in their life? All right, perfect. All right, this is for you guys. I'm standing on my soapbox, for the operators out there. But a little bit of my background. So, we're talking about our involvement in TC 1.4. So that's our control theory and application committee at ASHRAE. But I'm a voting member, YA subcommittee chair. So this technical committee is really there's a lot of other subcommittees that come out of it, but like producing all the technical documentation that, Ariana mentioned. I'm going to mention some, and Ron's going to mention some too, but there's a lot of good development as far as research and just even like specifications that, you have a brain trust of, I'd say the best engineers in the world, kind of talking and discussing, and sometimes not all of them always agree with everything, but it makes kind of a very valuable place to get that sort of information. And I'm also a chapter president in New York City. So there's a lot of outreach we do, and there's a lot of collaboration we work with a lot of other groups. But ultimately, to get that information that we're doing behind closed doors out to the masses, that's doesn't do any good sitting in a book on a shelf. And then ultimately where the rubber hits the road. My role as a project engineer, I'm going to sites. I'm speaking with operators and making sure what parts connect and don't, and really and so. Kind of the conversation or the title of this presentation is those operating training gaps, right? So identifying those gaps and finding ways to address them. So just a little bit of my background too. Like Ariana, I started as a controls integration kind of space. Worked on new construction projects as a design and PM, but new design work, but eventually worked in the existing building space. So in that you're dealing with a lot of operators, existing, trying to figure out what's going on now and trying to implement what the plan is, with the new specifications. Design build's very similar, but this time I'm writing the spec, but not only am I responsible for the integration and implementation, but a little bit of commissioning and measurement and verification after the fact. So you're dealing with after installation. I'm still there for 3 years, and I got to make sure everything's working right. Consulting, we'll talk about retro commissioning in a little bit, but improving this existing systems. So you have a really intimate relationship with the operators when you're making sure everything is going to work the way you hope. And then we'll talk at the end building analytics. So now I'm deploying a smart system, quote unquote. What are all you guys could imagine? What are all the factors that make it reliable to an operator? And what are the challenges you might face with those types of developments? With that type of developments for implementation. All right, so Ariana kind of had a slide on that. I know we spoke about it, but this is really meant for everyone. But I highlight these. Maybe first three specifically too, because they have control over a lot of the training and what the operator may or may not know. So for those consultants, manufacturers, owners, and really everyone who gets to interact with operators, it's really important to for that communication, and we all have a hand on the wheel for that the training that they might be able to understand for their building. Sorry, I'm just going to move this timer on my screen because it's okay. So if there is one thing I want everyone to walk away with is we're in our technical committee, we do a lot of good work. There's a lot of good technology advancements out in the world, right? And there's all these great things that we're doing to really highlight, to heighten. In this case, building controls is our example, but really everything in the industry. But I always think of this as like a chain link, right? So you have a chain link, right? And we're doing all these things to reinforce it. So is there an animation here? So you reinforce it, but if you forget the last chain, right? All that stuff just falls apart at the end, right? That chain breaks. It doesn't do any good for everyone. So that's my soapbox talk for the operator, right? They're the last step in the process. If they don't understand what's going on, then anything you might have done isn't going to happen really. And this is one of my quotes I've gotten, and it's probably the hardest one, but it's the most valuable one I've gotten. But I've done a lot of work in buildings with operators and a lot of improvements. But he was very frank. He's like, hey, I know how I like to run my building. I don't know what you're doing, and the second you leave, I'm changing everything the way back it is. And that's just frank honesty, and that really was a reflection of hey, how good a job am I supposed to do to make sure they understand what's going on, and that's really our responsibility, as people or anyone who works on buildings, to make sure that those designs come to fruition. So these are going to be two examples. These aren't the only examples, but these are two examples where we'll talk about process. And we'll talk about how we could leverage these processes for operator training. And you could, it's not, these aren't the only ways you could train an operator, but I implore you, to listen to the process and see if there is anything that can apply to maybe what you're doing, and I'll switch it over the other way too for the operators. These are the things as an operator, if I'm putting my operator hat on, these are the things I expect I would ask and make sure that I'm getting from my providers, right? So I know we have a lot of intro, maybe level people, but retro commissioning. You might hear it a lot of different ways. There's recommissioning, there's existing building commissioning, but really the idea that hey, you're tuning up the building, you're literally physically going through the building, you're surveying the building, checking that everything's working the way you expect it to work, and really doing that documentation to see where those those faults may lie, and really you kind of make this Chinese menu list all the possible things, and like, hey, really, it's meant for the owner to be like, hey, I want to be able to do this. I don't have to do it all now. I could, budget it appropriately the next year. I could, and maybe I don't care about this stuff, so don't worry about it. But what they'll end up using is like, hey, there's a lot of energy improvement opportunities during retro commissioning. So for an owner to be like, hey, what's the best bang for my buck with these measures? And we'll go through an example. But really the thought being like, hey, buildings have a long life cycle, right? We're advancing, how often are we advancing tech in every couple of years? But, the idea that, hey, we could have a system that's 20 years old, right? Maybe it was it's built and designed the way it was intended originally, but, there are new things we could be doing. And we just don't know, either one, we just don't know how to get there, right? Or two, we don't even know what it is. Again, back to after, but like there's a lot of things we've been in development with, just even within the past 5-10 years that, really kind of you could take advantage of. And the trick is what's the most efficient way to get those items. And we mentioned a few ASHRAE documents, like guideline 36 we're gonna focus on a lot for sequences. But how do we get that to the owners or to the buildings? How do we make sure that they're understood by the operators, right? So here's a retro commission example. It's a site I worked on in New York City. So 3 million square foot, really large commercial building, but a 20-year building automation system. I'll even say it's 2 building automation systems because they couldn't figure out how to connect them, or they couldn't figure out how to replace them originally. So that was like no one really wanted that there. But again, obviously what the owner was looking to do is, hey, it's time to upgrade, and really needed that retro commissioning as kind of like the proof, if you will, and the justification, to the financial side, like, hey, this is required, this is necessary. So we'll just go with an example. And remember, I mentioned, hey, there's like a financial component to this. Like, hey, so I'm highlighting static pressure reset here. It's one of the measures. Don't worry what it is. If it's, we'll go through an example, but the fact that, hey, there's going to be a cost to implement it, but there's an energy savings and a financial gain to it, and that's the when you're going to ownership, that's the call, or the dance you do, and try to make them want to pursue this. So what was it before? If this is the measure I'm providing now, what was it? What did you do before? What usually happens is, hey, you have a balancer going, and they're like, hey, we're going to do a balancing report, and this is whether it's based on design drawings, or they have to maybe modify something in the field, but here is the static pressure that you need to make sure all the air goes into the spaces you need to do. But again, there's nothing wrong with that. But remember, that's a snapshot. You're testing everything. This is one time. Hey, it's a static value, and like, hey, maybe it's I don't know how often they're going to do it, but it's probably the one time for the whole building, and it's like maybe not capture the seasons, might not capture anything else that might be going in the building, like occupancy. But what ends up happening is, like, hey, it's just one static value, maybe it's like 3 inches or something, right? And then what happens is it's just fat fingered. You just an operator will just like pop it in. Maybe they don't like it. After 6 months, maybe the fans running too fast. So let me make it 2.5 inches, right? All right, now I'm not getting enough air. Let me bump it up again. It's 2.7 inches, right? So there's a lot of and then the information gets lost. So it's just happens to be whatever it is ultimately. But what we do in guideline 36 is something called trim and respond, and not to just get into too much of the into the logic and confusing here, but like, hey, it just checks everything downstream. It's like, hey, it takes a poll of everything in the building. It's like, hey, do I need more air? Do you guys need more air? Are you good? And if they're like, hey, we're all like starving of air here, do you mind bumping up a little bit? Like, okay, well, we'll bump up the static. We'll increase it by 0.1 or something. Okay, and then checks it again 5 minutes. Like, hey, everyone good? No, do more. Keep going up, and then there's a point where like, hey, we're all good now. I was like, oh, all right, you're fine. All right, then I could probably bring it back down. Right. So that's why that's the trim. Bring it down, and the respond, bring it up. But if you listen to, what I described here and what I described, for the operator, wasn't it kind of the same? Like they were just like, hey, this is too much air. This is not enough air. Let me just modify the set point just a little bit. So like that kind of linking, right? That's the kind of like training that I'm talking about, where if I just dump this in a building and just walked away like, all right, this is your new sequence, have fun. And they're like, hey man, this set points, I've never seen a set point change before in my life. And now it's just going all left and right. And like, I don't feel good about this. I don't feel comfortable with it. Let me just override, right? Ariana mentioned it, right? Fat finger another value, and then I'm walking away, and then all that, let me go backwards. How much money did we spend on this thing? We spent $11K on it, all that work, all right, just disappeared, and you don't get any of the savings. So that's where I'm saying we got to leverage, that gap, so these things could come to fruition, right? So we mentioned guideline 36, high performance sequence operation. I read that regularly, and I bang my head against the wall a lot. It's very dense, and it needs to be dense because we need to there's a lot of considerations, a lot of configurations, but that's not a document meant to pass to someone on the sidewalk and like, hey, this is your sequence. I'll see you later. Good luck. But for us, especially those, exactly what we're doing here, providing these educational opportunities to guide others into, what the intent of the operator. Maybe they don't need to know exactly the way to tune the trim and respond value, but at least they get the idea and they're comfortable with it, and then we can continue on. But again, the way I like to, and then so just as a summary, so here's an example of hey, the money's there, right? And you don't want to fumble that chance for those savings. So let's make sure we could document those. And and once you document it, you have this opportunity of documentation and the opportunity for training. So, that's how that gap should get filled. I think I'm running a little high on time, right? Okay, so let me go real fast. Building analytics, data, just a lot. There's a lot of data in the world, and you want to do something with that data, right? That's how I think about building analytics, and you probably guys hear it all the time, but my thought on analytics is it's just a tool, right? It could do a lot for you, but you still need to be there, and there's a lot of actionable things you want to happen with the billing analytics, right? So for an operator, it's great if you have a great fault detection diagnostics system, and it could find, and we'll talk about it a little bit more, but they could find everything that you want to do, but if there's no way to do something with that information, right? If the operator has no idea what's going, hey, great, I got 100 different faults. Now what do I do, right? That's not, again, you're back to that example at the retro commissioning, right? It's not useful. You can spend all this money for, God knows what. So training is super important to understand how to use this tool. Okay. These are some examples, just, I specifically work with, but we're going to focus at my company, but we're going to focus on fault detection diagnostics. So that's, here's an example, but there's a lot of tribal knowledge sometimes with figuring out if something is going wrong. So I know I see a group of people that I probably know exactly what I'm going to talk about with this image, but for those who may not know, it can just raise their hands I'm looking at this image. I don't know what's going on, and this is a bunch of supply temperatures that in a non-24/7 operating building, and this is just a histogram. If you're working in a building, they're taking the information like this right now, but maybe you're not doing anything. So just to raise their hands, hey, I'm not sure what I'm supposed to see out of this. Does anybody? Okay, that's we got a couple hands, but for those that do know, they know hey, I see a flat line. I probably got something in manual, and someone's got to take that thing off manual, right? I see this weird pattern here on the red. Yeah, that's probably something where the set point's not being met. The equipment isn't running the way it's supposed to know. And let me just stop here. But those are things you could do with those senior operators that maybe a junior operator doesn't know. And you can apply this, and this is a quick thing here, but this is just 1 month, right? You can be doing that for how many more systems, for how many more time periods if you do analytics. So it's really important, and for that kind of scaling for the operator. It's one thing they don't have to do. That's one thing I did in retro commissioning, is I just download a bunch of this data. I'd spend months just checking things of hey, is this working right? Was this working right? And it's a big bandwidth of time. So applying that knowledge at scale and then like sharing that information with the team. So, and then of course, you know that during those non 24/7 operations, you know, there's potential energy too. So like, you know, if you don't do anything with these faults, they'll just, you know, you're losing those energy and financial opportunities there. So at least just the training gap here, you gotta show them. I mean, the way I always tell the guys in my company is, you know, the way to stay sticky is like, you know, they gotta want to use your stuff. So, you know, if I'm the operator, and this is, you know, to the operators now is, hey, this is what you should expect from a provider, right? You shouldn't expect them to be like, hey, downloaded my software. I'll see you later. Good luck. Let me know how it works. But you know, they should be showing exactly how it is. And I always process. We need to check that there's a way to leverage that information to action items. So quick summary. I mean, we went through that. But the takeaway for at least for my soapbox with the operators is, hey, any improvement to the building, you're doing documentation. So that's an opportunity for training, and take advantage of it. Sometimes things, you know, you might be proposing things that operator may not like, and you know, at the end of the day, it's going to be their building, it's going to be their responsibility. Don't, you know, I rather do some things and try to do all things, and you know, they change it back the second I walk out the door. So, and then the last part is like, hey, once you have an operator that knows what you're trying to do, they're going to be there 24/7, so they could be collaborating with you and making sure that you know, that your system's running the way it is. But I'll just stop my presentation. Thank you guys, and you know, if you have any questions, please reach out. Thanks.
All right, I'm going to go clean up here. So again, my name is Ron Bernstein, and I am a consulting engineer in a very unique space. We talked about backgrounds a little bit. I started off as a robotics and automation engineer back in the 70s and 80s as a factory automation guy. So I was a control geek from my teenage years. So I got into this industry basically through the gap between commercial and industrial, and then a little bit of residential. So I work with very large end users trying to develop a strategy for building enterprise-wide building automation control systems. I develop and write specifications. I write Division 25 specs. Many in the room know what a Division 25 spec is? Oh, okay, not many. All right. That's the integration stuff. That's where you bring it all together. That's the thing that always gets left out of the projects. That's left up to the controls engineer at the last five minutes of the project to go figure out. And then the commissioning agent has to sort it out from there. So I am going to talk about a project that I did in conjunction with the U.S. Department of Energy to address the gaps in the knowledge base of what's coming out of education training programs and the workforce. So I'm going to pepper that with some of my own thoughts and some of the results of this research report that we're hoping will be published very soon. So this is something we finished up last year. The intent of this project from the DOE is to develop a recognition program for any training school, enterprise, owner, vendor that produces training programs and has people going through those training programs that meet a set of criteria defined by the Department of Energy. So basically it's trying to encourage the universities, the trade schools, the online programs to teach to the requirements coming from industry rather than, as somebody said, the professor that had some crazy calculation that you're never going to use again because he was doing some research and needed free labor, right? And that's what we do when we're going to grad school. So we have hiring challenges in the industry. We're plagued with this disruption of lack of new people coming into the industry, lack of qualified job applicants, and paying people for the value that they're worth, that I think one of you mentioned, I think Ariana mentioned. So we're looking to improve that knowledge, and we have disruption factor. So here's some of the metrics. Where are we going? From 2001 to 2030, you can see the building automation growth in the market is ramping up rather dramatically. If you looked at other sectors, not as much. I would say IT, building automation, and in some cases, manufacturing jobs are growing, but others are diminishing as the workforce gets older. So we have a significant growth. There's advancements in technology are driving this. So a lot of the things that both Greg and Ariana mentioned are driving the need for understanding how buildings are built and the more complexities. Guideline 36, very, very more complex than what most people are used to. That means that you need a more educated workforce to do that. And lack of well-trained entry and intermediate. We're not only talking about entry level, we're talking about intermediate. How do you upscale or upskill your workforce in order to fill the gaps as us older gray hairs are starting to retire? So here's another chart that I pulled that talks about the building automation system industry. And of the 5 sectors, of the 5 different colors there, HVAC, energy systems, others like vents and plumbing systems, safety, security, and sanitation, by far HVAC is the biggest one. HVAC is the most pervasive one on the growth of the buildings market. That's the dark purple there. So we're continuing to see growth, and we're continuing to see more integration of HVAC with other systems. That Div 25, integrated automation, and then digital twins and enterprise systems all kind of play into that. So as we're looking at what a career path would be for an individual, what does that look like? Where are we going with some of these competing factors? Hiring managers looking for certain types of people that have certain educational basis that can grow into a position. Versus just picking somebody that comes from some university that has some course catalog that goes with it that may not match what we're looking for. There's a significant amount of in-house training. So rather than relying on the 7 schools you brought up, people are doing it in-house. Controls contract. Any controls contractors in the room here? All right, you guys keep your hands up if you have in-house training for your new hires. All right, are you expecting them to come on the job the first day and know how to do the job? No, it doesn't happen. But in other industries, you kind of are. You're supposed to learn from school, and that's what you're hiring people. And that's where that knowledge gap and that price gap comes in that was talked about. So we're looking to increase that. And you guys all know the difference between IT and OT, operational technology, informational technology. We have a tremendous gap in the industry of what the differences are and then how to work together. I often say it's easier to teach an OT person everything that they would need to know about IT than it would be to teach an IT person everything you need to know about OT and building technology. All right? It's just easier to do that. We have ways of doing that. We're looking at building a new ASHRAE Learning Institute class on the IT networking and infrastructure for OT systems, for building automation systems. Kind of like a BAS control infrastructure for dummies. And we talked about that at our recent meeting. So I'm going to keep going because we're running a little late on time here. I want to cover a couple of things. In the job market, we're focused on upskilling and creating this culture of value for the jobs and what's being needed in this course curriculum. So as I mentioned, this was a research project that the outcome of this project is to influence that set of criteria that would be a measurement against a training program. So this was the scope of the problem. My eyes are not as good as they used to. I need to make that a little bigger on my side. So developing training and education criteria, that's what goes into the course curriculum. The pre-course curriculum is developing the criteria for what a training program might include. Providing the guidance on for hiring managers, developing a recognition program. This is sort of like Energy Star. Anybody familiar with Energy Star? You go into Home Depot or Lowe's and you see the tag and it gets the energy rating and it's got its Energy Star rating on it. This is sort of a an Energy Star program for training and educational programs. That's what the goal of this was. Encourage more training classes that teach to that job criteria, enable and improve the OT skills market, help fill the job gap, provide industry guidance, and create a job task analysis for the OT sector. And through a process of interviews, I think there were maybe a couple of people in the room that I might have interviewed during this, we developed this approach of defining industry research, getting some subject matter experts to combine their knowledge into what this set of criteria might look like, doing some extensive interviews, and developing a skills matrix that we would use as the foundation for maybe a hiring manager to look to see these are the types of skills we'd like our new hires to include. So I'm going to share with you the criteria, and we then make some recommendations. So this is our criteria, the categories. So just keep an eye on this. The number of categories and the scope that we came up with in an OT world is extensive. You heard a lot over here, but you didn't hear half of what the job requires for somebody who's putting in or managing an operation using a smart building today. Just a little aside, this morning during one of the other sessions, I had an emergency call from a building that went offline. Well, what does that mean when a building went offline? Well, they couldn't talk to the BMS anymore because there was no more network connection, because this network connection is using a cell modem interface that's 100% air gap from the IT system. Turns out that there was a power glitch, and whoever put in the cell modem plugged it into the wall rather than into the UPS. Okay, simple things like that took down the visibility for a 600,000 square foot building for about 2 hours. That was this morning, and so we got it back online in about 10 minutes. But that type of stuff shouldn't happen. There should be ways to handle that. So that was the criteria. You can read them all there. We then went and took all 22 of these criteria or these categories, and we built out a series of criteria or statements of how to demonstrate proficiency in those areas. And I'll show you a few of them, not all of them. And then we defined them by the category of job applicant, a basic, intermediate, advanced, and because it's the Department of Energy, it was also related to energy skills. Anything related to an energy skill that we could say, okay, upskill your workforce because it's going to help drive and save energy and do our decarbonization. So these are some of the criteria that we came up with. We then looked at the job structure, the state job stakeholder structure, and we looked at the various levels from the employer type, from owners, contractors, installers, technicians, and the engineering and design, all the way down to the types of markets that would feed that set of criteria. So 22 categories, we had 297 job skills identified. We did a full job task analysis of 297 skills, and I'll show you a few of them here in a minute. We then took that and said, all right, in order to develop this criteria listing that you could get certified to, we broke that down or combined that down to 40 measurable skills criterias as a summary of that JTA. We took the subject matter experts into account, we prioritized those, and then we took some industry research of job postings in this industry and what people were looking for. So here's some example criteria that comes out of it. I can't list them all here. If you want a copy of the report, just come and grab my card, send me an email, and I'll get you a copy of the report. The ability, so first one, demonstrate the ability to manage, maintain, diagnose, and report on building, control, and automation equipment, subsystems, campus, and the use of portfolio, campus, and enterprise level applications and tools. That's a mouthful. That was probably 15 individual criteria that we had to combine down into one statement that you could measure a course curriculum on, which is pretty extensive. So another one, demonstrate basic energy monitoring management diagnostics as applied to building automation and management systems. Another one, demonstrate the understanding of building automation and control system design, architecture, components, networking functionality, and performance. So you get the idea that there's a lot to this. Some of the soft skills that came out of this, good people skills, good communication skills, skills that related to job, as in how do you bid a job? How do you do a takeoff on a job? What's a sequence of operations? All the things that I think both of the other folks here were talking about. The last one here, demonstrate the ability to develop energy efficient HVAC design, system integration, and management, including usage of trending, monitoring, alarming, and key performance metrics. That's a big, bold statement that is something that you could develop a course curriculum to. Oh, there's another one here. So I can move this out of the way. Demonstrate basic understanding of cybersecurity risks of building automation and control system design and implementation. So if you're going through like an undergraduate degree, you might have a course in a couple of these that would then lead to a credential or some level of proficiency. So that was sort of our goal. Oops. Here, within this project, is to then take that and build out a course curriculum for every one of those 40 criteria. So what would be included in a course that would include the knowledge needed in order to enter the job market for that type of skill? So that's something that we're looking at hopefully doing this year, if it gets funded, and then take that job task analysis to the next level on course curriculum. So this is something that's in process now. And then engaging with other training entities. These are programs, universities, trade schools, in-house programs, online training resources that you could maybe use in-house to upskill according to this set of criteria. And then provide industry training resource list. So where do you go? So Ariana did a web search and found a few schools. Well, one of the goals here is to provide a listing of all of those training entities that provide this level of training that meets the OT responsibilities for jobs entering the market. So we want to provide that list. That's another objective. So that's the end of my pitch. I will stop there and let's open it up to questions. Anybody have any questions, concerns, comments? Anything you want to bring up? Everybody well trained and educated in the room? Nobody needs a new upskilling? Yeah. Nice and light.
You mentioned OT technologies and IT technologies and GWAC and others. Trying to bridge those with training. I think there's a third element to this, application knowledge. Because one thing that is seriously lacking in the automation space is the actual application knowledge of how a field works.
Right.
Mechanical systems, electrical systems, plumbing, all the different things that automation touches. The application knowledge is the real gap I see in our space, because we're always trying to figure out where do you put that, what kind of people do you go after? Do you find somebody that has an IT savvy, bring them into automation and try to teach them how a building runs? Or do you go find somebody that has a mechanical background and then teach them how IT systems work? And, every now and then you find a unicorn that's able to grasp both concepts, but it's tough, and that's what we're all hunting for, or at least we're trying to train them to teach them.
Well, so let me just in summary, if you didn't hear all that, this is the kind of the three-legged stool. One is the OT, one is the IT, and one is the, let's call it the application or the big picture. And how do you find people that can bridge all three of those together? I agree with you. And I do put my stake in the ground that it's easier to teach somebody who has a big picture and an OT background, the things that you would need to know on the IT side in order to keep your building safe, secure, cyber secure, and functioning to the degree that you need it operating. It's easier to teach that OT, the IT level pieces of that to somebody who has that knowledge. So to me, I would be looking for someone who could grasp the big picture of all the different systems in a building, rather than just bringing in an IT person who knows routers, switches, ports, and all the three-letter acronyms that go with that, and trying to teach them the fundamentals of valves and dampeners and pumps and VAVs and, the 38 different systems that are in a building. That's going to be tough because it's you just right brain, left brain. It's not going to match. And I have experience on a real project going on now where we air gapped OT from IT, and we need to tell IT what we're doing. And then management came in and says, well, you're bringing a new technology, you got to vet it through IT. So what do you think happened? There's two things that happened during that process. Well, not nothing. Number one, the budget tripled and the schedule got delayed by 3 to 4 times, like another 2 years worth of delay once we did that. I've had that on multiple projects. I had one project where the owner, large government entity, decided that they were not going to tell the IT department of the large government entity that they were putting in a complete fiber optic backbone through this facility. It was a large hospital that's going to run the building automation control and management system. Complete backbone in through the entire hospital, until one day he said, hey, that looks like a fiber optic switch. That's not one of ours. Whose is that? Well, we put in the system, they still haven't told them what's going on in the network there. And it's not connected to the internet. It's completely isolated. There's a segmentation model there of both knowledge and architecture. That was a choice because they said they had to do the upgrade on the building, but they didn't have the money or the time to engage a full-blown IT solution. How do we deal with that? Well, we start with trying to find those unicorns or bring those unicorns up to speed. Find people willing to learn and send them to some IT classes. Yeah.
So, when the curriculum gets described, build out, how long do you imagine it being, like, in terms of hours?
Well, you're talking about for this program? So this program is not going to be a single class. It is going to be many classes that teach you remember going back here to these categories? Where's the category list? Yeah, so this category, you might have one class for each one of these categories. Right, and that's how my vision is that you can't overlap your basic communication and project management skills with cybersecurity and IT. They just don't fit. But if you were thinking, hey, if I were to hire somebody coming out of university that had 22 classes over 4 years that included one class in each of these, I'd be golden. I'd take that person any day of the week. Even if they only got half of the material, they were exposed to all the things that we deal with on a kind of a daily basis. You guys want to? I don't want to hog here. You guys want to chime in on this? You can always just comment. Yeah. So that's my vision, and I'm hoping that ASHRAE will start doing some classes that relate to these categories specifically. I mean, we've done seminars. We did a cybersecurity. We did a one that's not in here that sort of is there's AI. So we have the IT. There's actually AI and IT kind of in the same. We've done things like that, but I think they need to be a little bit more formalized from the structure of what is it you need to know in your job. That's my take on it. Any other questions?
You can ask us questions.
Come on, you guys got to ask them something. That's you're
The AI section.
AI, for what? Their ASHRAE or for?
No. AI.
yes, sir. Back there.
This is a big problem. We just have a building automation system to sell and see not work out. And it's been on company. And but like, how is this done in other countries? I mean, this looks great. Dissecting it, going about trying to find that.
Go for it.
Control sequences, how the system architecture and all that stuff. Yeah. That's fun.
So my experience in other countries is actually even worse. So we were brought in to Macau to go fix a system that was more broken than any system I've ever seen, because they independently hired the electrician and the pneumatics guy and the controls guy, so no one actually owned the system. So that's my very small experience abroad, but that was contracted with the Australians. And I think as you walk around here, right, like you have Siemens is from Germany or Switzerland, and I think this is a global problem. Like I don't walk into hotels abroad and do not like blown away that their hotel system actually works better than Yeah.
Hospitals,
Yeah.
you know, worldwide,
Yeah,
real high-tech stuff.
yeah,
That demands high-tech control systems.
yeah.
How's everyone else doing?
Well, I can answer it from the standpoint of the way projects are contracted in different parts of the world. You hit one where it's kind of ad hoc versus others, and mainly some in Europe, that are more integrated design and construction. So the general contractor, the design engineer, and the architect are all one firm. They do everything, and they do basically a design build, and they're responsible for integrating everything. It's a different way. It's not using the divisions of labor. That's not a union thing where you have to keep your division 23, 4, 5, 7 separate. It's all integrated under, in some cases, one workforce too, by one contractor that has the ability to do that all. I've seen that in Europe. Part of the challenge there is the prices are higher, the costs are higher in some cases to do that, because there's, you know, not as much competition. But it's a problem everywhere. Absolutely. Yeah. 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 Yes, sir.
So this is your vision for future certification. So early on, you asked to get involved with what are the places start involvement now? And we all have businesses and buildings that have methodology that describe. And this is a great stakeholders. We can do places for
Well, I always point to what's currently available through organizations like ASHRAE on the mechanical side, IEEE on the electrical and power side. What's the National Electrical Contractors, NECA, and the IBEW have their joint JATC Joint Apprentice Training Program. They have great training programs. I've was an instructor there for years, teaching OT and mechanical things to electrical contractors. They were trying to bridge that gap. The lighting industry is also looking to converge with the HVAC industry for sensor grids and occupancy and zoning. So there's some training in the electrical or in the lighting side with an organization like ASHRAE for lighting called the Design Lights Consortium. They put on a lot of training programs. They did a program here at HR Expo last year on the convergence of lighting and HVAC as a design principle and how to bridge that gap from the engineering perspective. So there are programs. I think that there's a gap, not only in the focus of any one organization like ASHRAE, and we really have to influence the training entities, the schools, the trade schools, the universities, the programs where people are going to get that knowledge. We got to start somewhere. And this is, hats off to the DOE for recognizing this. This came out of the Building Technology Office, BTO, which I'm not sure exists right now anymore, but whatever that group was. But they certainly need to see that in not only our industry, in lots of industries, but they're trying to do something about it by at least recognizing the problem, defining the criteria, and doing some steps to provide resources for that. Volunteer, that's another big one. If you have some knowledge in your company and say, hey, we can teach a course on air balancing, we can teach a course on the fundamentals of commissioning. Just, jot down what you think the criteria or the curriculum would be for that and pass it along. I'll take it, I'll feed it up to the DOE. Grab one of my cards. I love that. With that, I want to say thank you. I'll put another plug in for the GWAC session starting in a little bit in 226. We'll learn about the smart grid and integration into the smart grid from smart buildings. Thank you.
Yeah, everyone.